Hello everyone, welcome back to my YouTube channel SummarizedAI. As part of today's video, we are going to talk about React agent in LangGraph. React stands for Reason plus Act. React agents approach problems the way humans do. Let's try to understand them in detail. Suppose we asked a question or given input to our agent. Now, instead of blindly executing a fixed set of steps, a React agent thinks first. It looks at the user's goal, the current state of the task, what information is missing, and then it asks itself, what is the next best step to move closer to the goal? This reasoning step is what makes the agent intelligent, not just automated. Once the agent decides what to do, it takes action. These actions usually involve calling external tools such as a search engine, a database query, an API call, a piece of code or function. Instead of guessing, the agent goes out and fetches real information or performs real work. This is a huge shift from traditional LLM usage, where the model only generates text. After acting, the agent doesn't immediately respond to the user. First, it observes the outcome and try to find out, did the API return the expected data, or did the search results answer the question, or last, did the code execution succeed or failed? This observation becomes new input for the agent. In other words, the agent learns from what just happened. Now, here is what React truly shines. Based on the observation, the agent may decide to take another action, may correct a mistake, may choose a different tool, or may conclude that the task is complete. This reason, act, observe cycle continues until the goal is reached. There is no fixed number of steps here. The agent stops only when it knows it's done and the final output is generated. Now, let's try to see one of the use case which we are going to implement as part of this video. As we know, everything begins when the user asks a question. For example, what is 25 multiplied by 4 plus 10? The question enters the system and the workflow starts. Think of this as pressing the start button. Now, the agent pauses and thinks. It asks itself, do I really know the answer, or do I need to use a tool like a calculator to be accurate? This is the reason step, the brain of the agent. If the question is simple, it might answer directly. If the question needs calculation, it decides to use a tool. And tool is nothing but a Python function. If the agent decides it needs help, it acts. In our example, it uses a calculator tool to compute. This is like a human saying, let me quickly calculate this. Once the calculator as a tool finishes its job, the agent looks at the result. This step is called observe. The agent now has new information, just like, okay, the calculation says the result is 10. Now the agent asks one final question. Do I have everything I need to answer? Now we have two possibilities here. The first one is not yet. In this case, it will go back and think again. And the second one is yes, I have the final answer and stop and return the final response to the end user. This decision point is what makes the agent smart and flexible. Now let's go to our Visual Studio and see its implementation. Let's first create a file langgraph underscore react.py. Before we start our implementation, we require some of the libraries to be available in our local. And the very first library, what we require here is langgraph. Now after langgraph, we require one of the library named as langchain underscore OpenAI, because we are going to use one of the OpenAI's model, which is a GPT-4o mini. Okay. Now, after this, we are going to use some of the core features from LangChain. So there we require LangChain underscore core. Now, to install all these three libraries in our local, either we can go to our command prompt or in our ID's terminal. So let's go to our ID's terminal and copy paste this command. Okay. Now, as soon as you copy paste this command and hit enter, it will start installing this particular library in your local. And similar thing we can do with other libraries also. So let's paste this also and paste the core library also. So let's paste it here. All the libraries got installed in our local. You would be seeing one message here, requirement already satisfied, because I'm already having this library installed in my local. So I was just giving a demo like how to install these libraries. Okay. Now I have these libraries available in my local. I can go ahead and start the development. Great. So once you're also ready, then let's start the development together. Great. Now, the very first thing, what we need is the type dictionary and the list. Type dictionary we require for our state management. Okay. And we will see like how we can use this type dictionary in our state management for shared state. So let's import. So we can say from typing, import typed dictionary. Okay. And apart from this type dictionary, we require a list also. Great. Now from LangGraph, okay, from LangGraph, we require to have this graph, okay, because we are going to import state graph, okay. Now state graph will allow us to create the node and the edges, and we can define the complete flow for our graph from start to end. Great. Now we talked about start and end. So there we require to have the start state and the end state. Now the states which are going to be in between, we will be creating those steps as part of the code implementation. Great. Now after this, we require to have langchain underscore OpenAI, because from this we are going to import chat OpenAI. Okay. Now apart from this, from LangChain underscore core, we require to have messages, because we are going to import human message here, AI message, and the tool message. Okay. And I will tell you everything where we are going to use this human AI and tool message and how we are going to consume. So don't worry about that. Now, after this, because we are going to use tool message, then we require tools also from core. So we can say here from LangChain underscore core dot tools and import our tool here. Great. Now, these are the only imports we require to implement our current React agent. Okay. Now, the very first thing, what we are going to create here is the tool. So the tool, what we are going to create here is the calculator, and this is what we discussed earlier. So define calculator, and calculator is expecting a expression in the form of string. Okay. So let's create that. So you can just expression and then type of string. Great. Now inside it, we will provide the string doc. Okay. And what we are seeing here is evaluate a math expression. Okay. Great. So whenever our LLM is going to call this tool, it will have the context. This particular tool will evaluate the math expression. Okay. Great. Now after this, we can simply return the string. So we can say return and then string. And here we are just going to say evaluate the expression. That's it. We are done. Now here we are planning to return the string. So we will write str. Great. Now after this, once we have this tool with us, okay, we require to create the list of tools. So at current point of time, we are going to work only with the calculator tool. But if we have multiple tools like the search tool or API call tool, those tools, so we have to bind all the tools together so that our LLM can refer all of this in one shot. Okay. And which one is required? Our LLM will be intelligent enough to pick this tool based on the doc string here. Okay. So let's create the list of tools. So we can say tools equals to, we have only one, so we are saying calculator. If we have more tools, we can provide those tools, comma separated here. Great. Now our tools is with us, okay? And then after this, we can create a tool map. So tool map is to check if this particular tool is there, or for just the sake of compare, we will discuss where we are going to use this tool map. So we are going to say tool dot name colon tool for tool in tools. Okay, great. So we are saying whatever tool you are having in tools, just get the name of all tools. That's it. Okay. Now, because we have imported this typed dictionary, which means we are expecting to have the shared state. Okay. And as discussed earlier, shared state is nothing but the common location where our node will write the output, and the every other node will read that output and perform the operation. So for the other nodes, it will be a kind of input. Okay. So let's create that state. Okay. And point to be noted. So if we have multiple nodes in our graph, this is the way where every other node can communicate with each other. Okay. So let's create class agent state. And here we can pass the type dictionary. Now we are going to have only one property here, which is messages of type list. Great. Now we have tool, we have shared state. Now what we require here is the LLM. Let's create that particular LLM object from the chat OpenAI. And as we already know, to create an LLM, we require two things. The very first thing we require is the model. And the model, what we are going to use here is GPT-4o mini. This is the model we are going to use. Now, after this, we require to have the API key. Now, this API key, I have already created a detailed video. You can go ahead and check that video. It will provide you step-by-step guideline to create the API key. It will not take more than 2 to 3 minutes. So you can go ahead and create that API key. So I am already having this API key with me. I'm just going and copy pasting this key here. Okay. Now our LLM model is all ready. Great. Now, as discussed, we require to have reasoning, then act, and then observation. Okay. So let's create the function for all these nodes, and we know like node is nothing but Python function. So let's create these functions one by one, and then we will keep these functions as a node in our graph. So the very first function what we require is a reason. Okay. So here we by default require the state, and state is nothing but agent state. Now again, you can provide the string doc here, and you can say LLM thinks and decide next action. Okay. And here you can just say simply response equal to, you can invoke your LLM. So before you invoke this LLM, okay, you have to attach all of your tool with your LLM. So there we can say LLM underscore with underscore tools equals to LLM dot bind. The bind tools method will allow us to bind our tools with the LLM. Great. So here, just say tools. Great. Now this is done. Now here in the response, we can simply say LLM with tools dot invoke. Okay. Now, for example, if you're writing LLM dot invoke, okay, then in this case, it will not refer to the tools and directly answer the question. But here we are saying we have LLM with the tools. So before answering any question, you can refer to these tools and then answer that particular question. Great. Now we have this invocation method, and here we can simply pass our user input, which is in the form of messages. Okay. Great. Now this is done. Now we have the response also. Now simply we can return the messages here. So we can say messages, okay? And then again, here you just say state, and then again messages here, and plus the response what we got here. Now point to be noted here, whatever messages we got earlier, we are passing those, okay? And also we are passing the current response. Now because messages is a type of list, that's where we cannot pass it something like this. So we have to be pass it like a list. Now our reason function is ready. What we require is next act. So let's define that. Define act. And here again, you can say state and just provide the agent state here. Now here you can say execute tools calls. Okay, execute tool calls. Great. Now here, what we are going to do, we are going to fetch our last message from the messages. And to access the last item from the array, we are going to say -1 of the last messages. So here we can say last underscore message equals to state, just say messages, and here simply -1. Okay. Now after this, you are going to check one thing. If last message dot tools is not there, tool calls, then you have to return the state as is. Okay. So let's say this last message dot tool underscore calls. Okay. And then what you have to do, you have to return the state as is. Nothing is required. If this is not the condition, then what we are going to do, we are going to get the tool call. So tool call equals to last message dot tool underscore calls and get the zeroth element here. Okay. Now, once you have this, you can get both the things from the tool call. You can get the name of the tool and you can also get the argument. So here you just simply say tool underscore name equals to tool underscore call and just pass the name key. Similarly, if you wish to have the tool underscore arguments, so for that also, you can again say tool underscore call, and inside this, you just pass arguments. Okay, great. Now, before I proceed further, let me do one thing. Let me just print this particular LLM with tools here. Okay, and see like what we have here. Okay, so if I execute only this piece of code, so if you can see in the output, when we print this LLM with tools, it provide the complete information about the tool. So if you see here, it says tools, and the very first tool here we has name is calculator. Okay, and the description is nothing but whatever doc string we have provided, that particular doc string it considered as the description here. Evaluate some math expression. Okay, great. And this is how our LLM read all these functions in terms of tools. Great. Now let's proceed further. So we were here and we were able to get the tool name. Okay, and we were also able to get the arguments. So name we got from here, but the argument we will get once we will get the input from the user, and that is nothing but the query which is passed by the user. Now let's invoke our tool here. So we can say result equals to tool map, and here you just pass the tool name. Okay, and then you can say simply invoke, and inside this invoke you just pass the arguments, which means you are invoking this particular tool with this input. Okay, and it will provide you the result. Great. Now here the tool message will come in picture. So tool underscore message equals to, we have this tool message, and inside this tool message you can pass the content equal to result comma tool underscore call underscore id, which is going to be tool underscore call. Okay, and then here you can simply pass the id. Now here the tool message will allow us to send the result of a tool execution back to the LLM, so the model can continue reasoning. That's where we use this tool message. Now return the messages. So you can simply say messages, and here you just simply say state, and here messages plus tool underscore message, whatever we are getting here. Okay, great. So now this act function is also ready with us. Now the next function, what we require here is observe, which is nothing but should continue. It will decide like what to do next. Should I continue or end the flow? Continue if we did not get the expected result, and if we got the final result, and we can return that particular end result to the end user. Great. So let's create that should continue function. So simply you can say define should underscore continue. Okay. Now this will also take the state agent state. Okay. Now after this, again, you are going to provide the stock string here. So decide whether to continue or finish. Correct. This is our expectation with this function. So now here again, you can say last message. And as we know, the last message is nothing but the state. And from state, you just get the messages and the -1. So you will get that element. Now you can simply say if is instance, okay, last message is of AI message. Okay. If this last message is the instance of AI message and condition and then not if we don't have last message dot tool calls available, then you should return and it will end the process, or else just continue. Okay, so if you see here, it is saying if it is an instance of AI message, the very first thing, the very first condition, and if we don't have any tool calls remaining, just end the flow. We don't require any other call. We can terminate the execution. But if we don't have this condition true, then we can continue with our execution. Great. Now our functions are ready. Now what we have to do, we have to create a graph with the help of shared state and convert these functions into nodes. Okay. And we require to have the edges to connect these nodes. So let's do that. Let's first create the graph. And to create the graph, we have already imported this state graph. Okay. So let's use that. So we can say graph equals to state graph. And here you just pass the agent state. Now, point to be noted here, I have already created a detailed video on these tools or the state graph and what is graph, how these nodes, edges, paths, other things are working. You can go ahead and check out that video. It will help you to understand things in detail. But don't worry, I will explain the graph here also on the high level for sure. So let's proceed further. Now we have the graph object. Now inside this graph, we can add the node. And as you know, we have two nodes to add. The very first node we have here is a reason. Okay. And the reason is nothing but it will call the reason method. Now, after this, we have one more, which is nothing but act. Okay, great. Now, after this reason and act node, what we require to have the edges from where the execution will get start, from start where it will go, how the flow will get start. And from start, it should go to the reason, and from reason, it will go to the act, and from act, it should end the flow. And in between, it will call the conditional edges also. So for example, this one here, it will decide either to continue or the end. And if to continue, you have to call the reason node again. So let's create that kind of flow. So you can say here graph dot add edge. Okay. And the very first edge we require is the start. That's where we have imported the start here. Now from start, it will go to the reason. Okay. And as we know, from reason, it will be going to act. So let's do that. So from reason, it will be going to act. Now we require the conditional edge also. So where it will decide either I have to continue or end. So for that, we can simply say graph dot add conditional edges. Okay. Now, as soon as you talk about the conditional edges, once it will execute this act. Okay. And whatever output we are going to get from the act. Okay. it will go to should continue. Okay. And whatever should continue is returning as continue or and where we have to go. So if suppose if this is a continue, then you have to go reason. And if it is saying and, then you simply say and the flow. There is no node we have to call. Great. Now our overall flow is ready. Now what we can do, we can quickly compile this graph. Okay. So let's do that. So we can say graph dot compile. So as soon as you write this particular line, it will create a virtual kind of graph for us with the flow having nodes and edges. Great. Now, once we have this graph ready, we can go ahead and take the input from the user. So we can say user underscore input equals to what is 25 multiplied by 4 plus 10 and question mark. Great. So this is our user input. Now we are going to invoke this graph. And to invoke this graph, we are just going to say app.invoke. Okay. Now app.invoke will take this user input as a messages. So here we can say messages and simply you can say user input here. And before you pass this user input as is, you have to convert this user input into the human message. And how we can do that? So for that, you can simply say human message and inside it, you can pass the content equal to user input. Okay. Now, once we invoke this, it will provide us the response. So we can say result equals to, okay. Now, finally, we can print the result. So here we can say here, new line, and then final answer, okay. And then again, new line and say print result. And inside result, we have messages, okay. And from messages, you can get the -1 element and just get the content out of it. So this is our final response. Great. Now let first execute this piece of code and then we will try to understand the complete flow. Great. So let's execute this. Now we got our output. So it is saying final answer. The result of 25 times 4 plus 10, it is 110. Great. How we got this response? So now as soon as it will invoke the graph, it will create a shared state or the virtual memory, you can say, where we will save our messages. Okay. Now, once it saves our message as a human message, it will go here. Okay. And it will check for the start. So this particular step, whatever we have app.invoke, is the very first start step. Now from start step, it will go to the reason. Okay. Now from here, reason edge, it will look for this and reason is nothing but this thing here, this particular reason function. Now, once it goes to the reason function, our LLM with tool will get invoked with the message, what is 25 into 4 plus 10. Then it will provide the response, boss, I have a tool to access. You can go ahead and access that tool and get the output. So here it will pass the message as is, what is 25 into 4 plus 10 and the response. Okay. And in the response, we are going to have the tool call. So if I go here and just print this particular response, let me do that so that it will make things clear. So let's execute. So you can clearly see when this particular method got called very first time, it said, I don't have a content on the response, but we have to make a tool call. Okay, so this is the tool having name this and the argument, which is nothing but the user input. And this is what we discussed earlier. Okay, then you please make this tool call and get the output. So what it will do, it will save this particular user message and the response into the messages. Done. Now, after this, from start, it went to the reason. Now from reason, it will go to the act. Now the act will come in picture. Now here, act will fetch the last message where we have all the tool information. So we have tool name, tool description, and the tool arguments. So it will fetch everything here. Okay. And it will try to access the tool message and whatever tool message as a response we are getting, it will save here, which is nothing but it will say kind of 100, 110. Okay. Now, once it will return this messages, it will go to here. So act is done. Okay. Now after act, it will call should continue. Now should continue will see last message. What is the last message? It is saying the last message is having a tool call, which means you don't have to go inside it. Just continue. So now if we say continue here, then again it will call to the reason. So if you see the earlier output, okay, because after continue it is calling reason, our reason got called two times. Okay, so if I go here, first it called for this one, then the second reason this one. Okay, and the second time when it got called, it provided as the response. Okay, the result of 25 times 4 plus 10 is 110, and there is no tool call, which means we got our response. So as soon as we say continue, it went to that reason again. Second time, it execute this particular method again, and we got the messages. Now again, it will go to the act. Okay, there you will not find anything around the tool calls because we don't have anything, because we don't require any tool calls. So it will return the state as is from here. Now, after returning to the act, it will go to the should continue again. Now, in the should continue, it will see, yes, this particular message is from the AI message, which is correct. Okay. Now, the second, we don't have anything like tools in our current response. Then it will end the flow. And after ending the flow, it will come here. It will print this final answer. So from result, it will access the messages. And from the last element, it will fetch the content. So if you see here, it will fetch the content, and in the content we have the result of this and this. So the same output we have printed here. And this is how this reasoning act and the decision making, or I would say how this LLM observes the output, it works. Thanks for watching this video. Please don't forget to like and hit subscribe button. This is very important for me. Thank you very much. Have a good day. Bye bye.